Alright, welcome to day 2 of our video lessons. This is Chapter 8, Lesson 2. Just a reminder that you should be working on your Bigfoot problem throughout the week. So if you get done with homework today in class, it'd be a good time to run over to the crime scene and check out our evidence that was left behind and start working on that problem. Again, it's due next Monday. Alright, so today we're talking about characteristics of quadratic functions. So we're continuing on with quadratic functions. Also, when you checked your homework, if you still have questions, feel free. You can always email me questions that you have, or ask somebody else sitting around you, somebody at your table with questions, or you can wait till I get back to ask me questions. But feel free to email me with any questions that you might have. Okay, so characteristics of quadratic functions. The big idea here is what happens when a parabola crosses the x-axis. So you can see here, there's two crossings of the x-axis. Here there's one, this parabola is sitting on the x-axis, and here it doesn't cross over it at all. Well, these points where the x-axis is being crossed by the parabola, this is called a zero of a quadratic function. Because when the quadratic function is crossing over the x-axis, this means that y is equal to 0. So we call these zeros of the quadratic function. Okay, so we're going to look at 3 examples of these zeros. The first one, find where the function crosses the x-axis. So the zeros here are this point, and you can't really see it from my video, but hopefully you can look at your notes and see. So here's 0. There's -2, -4, -6. So it's crossing over at -4. And right there at the origin, so and 0. So -4 and 0 are the zeros of the function. Okay, so we're going to come back to this axis of symmetry here, but I want you to see that a parabola is symmetrical. We talked about that yesterday, but it's symmetrical along the vertex. Now the axis of symmetry goes through the vertex. Remember, the vertex yesterday we learned was that point where there's a change in direction. So I went ahead and darkened my vertex. And the axis of symmetry is the vertical line through the vertex. So it's a vertical line through the vertex. Now, so I'm going to shade in, I'm just going to do a dotted line, and I don't know if you can see that or not. I hope that you can. But there's my vertical line. And that's my axis of symmetry. So what's going on this side is the very same symmetrical. I could fold that in half and it would line up. They're symmetrical along the axis of symmetry. And so the axis of symmetry is a vertical line. And so a vertical line, remember, is an x equals line. A y equals is horizontal, and an x equals is vertical. And so this is x equals -2 because the axis of symmetry crosses through -2. So x equals -2 is my axis of symmetry. And that is actually the average between my zeros. So -4 plus 0 is equal to -4. Divided by 2 would be finding the average between those two numbers. -4 divided by 2 is -2. That's my axis of symmetry. So if you have two zeros, it's the average between them that's your axis of symmetry. Alright, so example 2, we just have one 0 here, so I'm going to cross out one of those blanks. And my only 0 is at -2. That's where my parabola is sitting on my x-axis. So my axis of symmetry here is actually just the my only 0, because my vertex is right there on the x-axis. So when I draw my line of symmetry there through the vertex, I can see that's passing through -2, so that again is x equals -2. So if there's one 0, then the 0 is the axis of symmetry. If there's 2, it's the average of the 2. Alright, example 3, there are no zeros here of the function. There's no zeros because it's not passing and never will, because these arrows are going up, this parabola is opening upward, never will cross over the x-axis. So my axis of symmetry I'm going to have to find by finding my vertex. Alright, and this is kind of in between points 2 and 3. So I'm going to call that vertical line x equals 2.5. If you disagree with me, you can write something else, but I think my eyes are good enough that it's there between 2 and 3. All right, so here's just kind of a table. It's going to help kind of sum up just what we did. So the definition is the axis of symmetry The axis of symmetry is a vertical line that divides a parabola into two symmetrical halves. So go back through the previous examples and draw the axis of symmetry. We did that as we were going through. But 1, 0 was this example 2, just 1, 0. 2 zeros was our first example. We had 2 zeros. So it's saying here that the axis of symmetry is the average. So that's written there for you. And then no zeros. So here we have no zeros. And so it's the introduction to this formula here. X equals negative b over 2a. And that's how we're going to find the axis of symmetry on all the examples on the back. And that's what you're going to use for your homework. So turn over to the back. All right, now we're going to practice finding this axis of symmetry. So it says the zeros of a function can also help us find the vertex of a parabola. And the vertex of the parabola is where that change in direction happens. So they want us to find the vertex of the function. So step 1 is they want to identify a and b. Now remember the standard form is y equals ax squared plus bx plus c. So here a is my coefficient of my x squared term, so a is equal to 5. And b is that second term that goes with my single x variable. And so b there is negative 10. Make sure you put that minus with it. It's a negative 10. Now they want us to find the axis of symmetry using the formula. And the formula here is x equals negative b over 2a. That's going to be something you want to memorize. All right, so negative b over 2a. Find the axis of symmetry. So we're going to go ahead and write that over here. X equals negative b over 2a. Now I'm going to substitute in my b and my a. Now be really careful because notice we have negative b here and my b is negative. Use parentheses when you substitute. So I have negative 10 in parentheses. I'm going to keep a negative outside of there. So it's a negative negative 10 all over 2 times a, 2 times 5. So a negative b, which my b is already negative, makes that a positive 10. All over 2 times 5 is 10. So my axis of symmetry, my x here, is x equals 10 divided by 10 is 1. And this is my axis of symmetry. So we just found the axis of symmetry using the formula. It's supposed to be an O, that looks like a D. Okay, so my axis of symmetry is 1. Now this is also the x value of my vertex. Remember, the axis of symmetry goes through the vertex. So now I just have to find this y in order to find my vertex. So I'm going to substitute 1 in for x into my original formula and solve for y. So over here I'm going to say y equals 5 times 1 squared minus 10 times 1 plus 3. So I have y equals 1 squared is 1, so 5 times 1 minus 10 times 1 is 10 plus 3. So we have y equals 5, it's supposed to be a minus sign, 5 minus 10 plus 3. 5 minus 10 is negative 5. Negative 5 plus 3 is negative 2. So my y value is negative 2. So write this as an ordered pair. My x value is 1, and my y value is negative 2, and that's my vertex. So I just found my axis of symmetry is x equals 1, my vertex is y equals negative 2. So now I could go and easily graph that because I know where my axis of symmetry and my vertex are. And I can also see that 5 is positive, so this would be opening upward. So I could have a rough sketch of what this parabola might look like. All right, so we're going to do the same thing on these next 3 examples. They just kind of space it out for us a little bit more. So find a. A here is 1. B is 8. So find negative b over 2a. So we have negative 8 over 2 times 1. So negative 8 over 2 is equal to negative 4. So there my axis of symmetry is x equals negative 4. So this formula here finds us our axis of symmetry. So my axis of symmetry is negative 4. Now my vertex, I'm going to have to plug in negative 4 into my original formula for x and solve for y to find my ordered pair. So I have y equals instead of just x squared, we have negative 4 squared. That's not the bell to leave. Don't get hopeful. So we have negative 4 squared plus 8 times negative 4 plus 12. So I have y equals negative 4 times negative 4 is positive 16, plus 8 times negative 4 is negative 32, plus 12. Now I can add these in any order. I'm just going to go left to right because I know 16 plus negative 32 is negative 16, plus 12 is negative 4. So my vertex there is actually negative 4, negative 4. So my x is negative 4, my y is negative 4, so I have the point negative 4, negative 4. All right, let's try our next example. So this one, our a here is 1, our b is negative 10. So we have negative 10 again over 1. Negative 10 is positive 10 over 1 is just 10. So my axis of symmetry is x equals 10. I'm going to plug that in for x into my equation. So I have y equals 10 squared minus 10 times 10 plus 40. And this is going to give me my y value so that I can list that as my vertex. So I have y equals 100 minus 100. Hold on, I did something wrong, didn't I? 2 times 1. Hello. You caught that. Good job. I didn't. All right, I've got my 2 times a, so 2a. So we have 10 over 2, which is 5. I thought something wasn't right. So this is x equals 5. All right, so let's plug in 5 for all of these. Sorry about that. Okay, so we have 5 squared minus 10 times 5 plus 40. So 5 squared is 25 minus 50 plus 40. 25 minus 50 is negative 25. Plus 40 is y equals positive 15. So my vertex here, my y is 15, my x is 5, my vertex is 5, 15. All right, and then my last example. Here my a is 2, my b is negative 8, so I'm going to plug that in here. So I have negative 8 all over 2 times 2. So negative 8 is positive 8 all over 4. 8 divided by 4 is 2. So my axis of symmetry there is x equals 2. Plug that in for my x to find my y to get my vertex. So y equals 2 times 2 squared minus 8 times 2 minus 3. So y equals 2 squared is 4 minus 8 times 2 is 16 minus 3. 2 times 4 is 8 minus 16 minus 3. So y equals negative 8 minus 3. So we add the opposite there. And so we get y equals negative 11. So my vertex, come down here and write it. My vertex, my x is 2, and my y is negative 11. So I have 2, negative 11 as my vertex. All right, I know I went through those fast, so if you need to rewatch the video tonight or even in class, you can ask the sub to replay parts of the video if you need to. But here's just kind of a recap. So now you know how to find the zeros of a function from looking at a graph, axis of symmetry by using a formula, which is negative b over 2a, and the vertex of a function by looking at the equation. So we have, our homework is page 535 through 536, numbers 1 through 18 all. Okay, so you have the rest of the class time to work on that. If you finish that, you can work on your Bigfoot problem. All right, see you guys tomorrow.